Hello all, this is Kinjal Patel and I'm presenting my application project that is flight delays and cancellations analysis. So our group number is 2 and members are Kinjal Patel, Umar Hussain, Kasima Bulen. So, motivation to know about flights with most delay using data which Department of Transportation collects from every flight in the US and their delay information. To analyze if any airline has considerably high delays, to get knowledge about most common reason behind cancellation of flights in a year. To know about long distance flights that travel, to know about count of flight cancellations happening every month in a year. So now design. So we used airlines dataset from 1987 to 2008. Here is the link, and the data set is from RITA. So each data set has more than each 7 million rows with 29 data information separated using comma. Information columns used from this data set are flight number, month, arrival delay, departure delay, distance, cancelled, and cancellation code. So, implementation and evaluation. So, we used Eclipse, Oxygen IDE, uh, SCP, and PuTTY. Eclipse IDE is used for writing code in Java. WinSCP is used to perform file transfer. PuTTY used to interact with server directly. And the data set, as I told you in my previous slide, that is airlines data set from 1987 to 2008. And here is the link. Hadoop MapReduce on Amazon Web Service, AWS, that is open source programming framework that can be used to efficiently process large data sets. The framework takes care of scheduling tasks, monitoring them, and re-executing any failed tasks. So we have done some analysis. So here is the first analysis, which is to analyze longest arrival delay of each flights in a year and find out the top 10 most delayed flights on arrival. So there are mapper 1, reducer 1, mapper 2, sort compare class, and reducer 2. So in mapper 1, mapper 1 performs the reading of data set, splitting two data nodes after generating key value pair of flight number and arrival delay from the data set. Reducer 1 gets only the flight's most delayed arrival delay value by comparing all the values of the key. Then it writes to a temporary file which is input to mapper 2. Mapper 2 performs the reading of temporary file and generates key value pair using arrival delay and flight number respectively from temporary file. So the sort compare class is used to sort the input to the reducer 2 in descending order of key, that is arrival delay, to find the top most delay flights using reducer 2. So reducer 2 reduces and prints first 10 key value pairs to the output file. So here is the graph of which we analyze. So here is the graph that is analyzed output using analysis 1 for year 2008 data set. And according to this graph, here is some output in which so flight number 800 has most delays, that is 2461 minutes, and And the second highest delays is 2453 minutes for flight number 1695, and the lowest delay is from flight number 511, that is 1000 that is 1583 minutes. So then we did analysis 2, that is to analyze longest departure delay of each flights in a year and find out the top 10 most delayed flights on departure. So there are mapper 1, reducer 1, mapper 2, sort compare class, and reducer 2. So in mapper 1, that performs the reading of dataset, splitting two data nodes after generating key value pair of flight number and departure delay from the dataset. Reducer 1 gets only the flight's most delayed departure delay value by comparing all the values of the key, then it writes to a temporary file which is input to mapper 2. Mapper 2 performs the reading of temporary file and generates key value pair using departure delay and flight number respectively from temporary file. The sort compare class is used to sort the input to the reducer 2 in descending order of key, that is departure delay, to find the topmost delay flights using reducer 2. Reducer 2 reduces and prints first 10 key value pairs to the output file. So this is the graph for flight delay on departure. So uh, and the x-axis shows the flight number and y-axis shows the delay on departure in minutes, and here is the output from the graph. So most delayed most delayed flight is 86, the number is 86, and the delay is 1930 minutes, and the lowest is 1591 minutes for flight 1114. Then we did analysis 3, that is to analyze reason for cancellations of cancelled flights in a year and find out the count of each categorized reason to figure the most common reason for the cancellation. It has mapper and reducer. So mapper performs the reading of data sets splitting to data nodes after generating key value pair of cancelled code from the data set, and value is equals to 1. Reducer adds the values of key to get the total count of each key, hence writes the final count of each cancel code into the output file. So this is the graph from analysis 3, which is cancellation reason graph. So x-axis depicts the reasons and y-axis depicts the cancellations counts, and the most cancellation reason is because of career, and then weather, and then national. So here is some analysis on cancellation counts for categorized reasons. So as we saw in graph, career has the most counts, that is 59,350, and security has the lowest count, that is 92. Thank you.
The next thing we looked at was the total number of times a flight got canceled and the flights with the most cancellations. So again, we mapped and looked at all the cancellations for each of the flights, and then here are the flights that had the most number of cancellations, so something like 100 for the top 2 most canceled flights. And then we also wanted to see what were the months in which we had the highest number of cancellations. So essentially, what are the worst months to travel in? And in here, you can see January is an outlier where it has the most cancellations. And then it's generally the summer months from June through August where they're still pretty high. It was surprising to see November is not that bad, considering you hear a lot of stories about Thanksgiving slowdown and so on and so forth in airports. One of the things we also looked at was how what performance was like as the size of the data increased, right? So we started with just 1 year worth of data, and you can see that the execution time was pretty low. And then as we added each subsequent year of data, the execution time started to climb. We also looked at the performance as it related to the number of virtual machines that we were running. So when we initially started, it was just one instance, and it came to something like 4.5 minutes of execution time. And then as we started adding the number of instances and we got up to 5, it came out to something like 1.5 minutes. And here are some of the top level conclusions that we came to, which was flight 5961, which was the flight with the most cancellations of something like 106. And it's sort of restating some of the other conclusions we came to. As the flight with the most delays on departure was flight 86 with 1,930 minutes. The best time to travel was in May, November. And the flight with the highest delay on arrival was flight 800 with 2,461 minutes. And that was our presentation. If you have any questions or comments, please feel free to let us know. Thank you.